Welcome to the Explainer. What if you could build a perfect millimeter-accurate 3D model of a real-world railway line? And what if you could do it with a drone you can buy right off the shelf? Well, today, we're going to break down exactly how one team of engineers pulled it off.
So let's get right into it. This is the core problem. You can't just fly a drone and hope for the best. We're going to see how a team of surveyors tackled this exact challenge, and they did it with a really clever mix of everyday tech and some serious pro-level gear.
All right, so the mission was to create what's called a digital twin, basically a perfect digital copy of a 1.15-kilometer stretch of railway in Spain. But they hit a huge wall right away. They had nothing to start with. No official maps, no survey points, nothing.
You know, usually surveyors can lean on existing official maps. It makes fieldwork way faster. But this team, they were in the second boat, totally flying blind. They had to physically go out there and create their own map from the ground up, which, let me tell you, is a much tougher job. So what do you even bring to a job like this? You're probably picturing some crazy, futuristic, million-dollar equipment, right? Well, the reality is actually a really smart combination of off-the-shelf tech and some highly specialized professional tools.
And here's the kicker. The star of the show is a DJI Mini 4 Pro, a consumer drone. The secret isn't the drone itself, though. The professional-grade accuracy comes from pairing that drone with a super precise GPS system and some seriously powerful software on the back end.
But listen, before that drone's propellers even started spinning, the most important work had to be done right there on the ground, on the railway itself. This is where true precision actually begins. These things are the secret sauce. They're called ground control points. The team put down 34 of them along the tracks. You can think of them like high-tech pushpins for the real world. Each one has an exact known GPS coordinate, and they create this bulletproof network that anchors all the drone's photos to reality.
Okay, so with the ground points set, it was finally time to get the drone in the air. Now, you'd think they'd use some special automated software for this, but nope, that wasn't an option. This meant the pilot had to draw on pure professional experience to get it right.
So yeah, this was not a press one button and go operation. There's no map the railway setting. It took an expert's eye to manually design the entire flight path to make sure they'd capture every single piece of data they needed. And this right here was their recipe for success. Every single parameter was dialed in perfectly. They flew low to get incredible detail. They flew slow to make sure there was zero motion blur. And they made multiple passes to guarantee all the photos would overlap. That overlap is absolutely crucial for the software to stitch it all together later.
And get this, after less than an hour of total flight time, spread across 5 flights, all the data was collected. Now the action moved from the field to the office, where the real heavy lifting began. The process is called photogrammetry.
And it really is heavy lifting. For each of the 4 zones they mapped, the computer had to crunch the numbers for up to 5 hours. It was basically teaching itself to see in 3D by analyzing thousands of 2D photos, finding the same points from different angles, and calculating their exact position in space. And the result is, well, it's this incredible transformation. You go from a folder full of regular pictures to this rich, complex 3D model. It's called a point cloud, and it's literally millions of individual points, each one with a precise, real-world address.
So what's the payoff? After all that work, on the ground, in the air, on the computer, what do you actually end up with? What can you do with this thing?
Well, they got 2 main things. First, that dense point cloud we just saw, and second, something called geo-referenced orthophotographs. Just think of them as perfectly flat, totally distortion-free aerial maps where every single pixel is tied to a real spot on Earth. But the real value isn't just having these files. It's what they let engineers do next.
All of a sudden, you can calculate the exact amount of gravel you need for a repair without ever leaving your desk. You can inspect a bridge for cracks safely from a computer. You can plan future construction with millimeter accuracy.
This digital twin becomes this vital tool that makes maintaining our railways safer, cheaper, and way more efficient.
It's just a powerful reminder that the line between consumer tech and professional engineering tools is getting blurrier every day. The ability to perfectly map and understand our own world is more accessible than ever, and that really makes you wonder, what's next?